Hello, friends. This is a podcast to introduce the concepts in Section 6.3. I'll do a separate one to do some example problems. You see before you the 5 probability rules, the basic ones that we've already talked about. You should be familiar with all these rules, the notation, and you should be able to apply these to any situation that gets thrown at you. Additionally, you should know what a union is. You should know that this is a Venn diagram. You should know that the area of this entire thing is 1. And that the area of each of these circles represents the probability that an event A happens, and that everything in this circle B represents the probability that B happens, and that this area in here is the probability that A and B happen at the same time. For the word union, you should know that that is the symbol, and that the word that's associated with union is or. So what I would say is anything that is in A or B is in the union. And remember, I talked to you about if you think of a labor union, all the workers coming together to have more bargaining power. All right, anything that's in A or B is in the union. Additionally, we've already talked about disjoint events, and you should recognize in this Venn diagram that A, B, and C are events that cannot occur at the same time because there's no overlap. And if I have disjoint events, I simply add all their probabilities. So for any number, this one has 3, but if there was 4, 5, however many, if they're disjoint events, to find the probability that one of them happens, I just add all the areas of those probabilities. So still talking about unions now. If you're looking for the union of 2 events that are not disjoint, all right, so this is a general addition rule for anything. If I want to find the union, which is anything that's in A or B, and again, this is the same notation just with that U, all right, I add all of A and I add all of B. But you see here in the formula that I have to subtract out the intersection, which is this piece right here. And the reason I subtract this piece out is that it's been added twice, once with A and once with B. So I have to subtract it out one time. So these formulas both say the same thing, and we're still talking about unions of any sets. And clearly, if they were disjoint, then this number and this number would both be 0 because there would be no place where they intersected. If you look in your book on page 438, you've got an example with Deborah and Matthew, I believe are the names, and they've simply applied the probabilities given in the problem to a Venn diagram. So you can see the probability for Deborah being made a partner in the law firm is 0.7, and the probability that Matthew is made a partner is 0.5. All right, and from this information, you should be able to find the probability that Deborah does not make partner is 0.3. The probability that Matthew does not make partner is 0.5, and that they've applied this whole situation. So this right here is the probability of D. You can see it adds up to 0.7. The probability that Matthew makes partner right there is 0.5. And then you've got the probability that David makes it and Matthew doesn't, that Matthew makes it and Deborah doesn't. Here's the probability that they both make it, and then this is the probability that neither make it. And this should all make sense to you, and you should be able to apply this to any problem that they throw at you like this. And this leads us into our stuff on conditional probabilities. You should at this point be familiar at least with the notation that is the probability that B happens given that you know A happened, and this you should already know. That's A and B, so that's the intersection and the probability of A. And this again, you've got that conditional probability for the intersection, finding the probability of the intersection. So let's hit intersection, make sure we're solid with that. Okay, intersection, you should know that is the symbol for intersection, and it's the word and. The intersection is where A and B happen at the same time. And we have a rule which says if A and B are independent, then I can find if they're independent, then the probability of A and B happening is just probability of A times probability of B. All right, we'll do some examples in the next podcast.